Hello and welcome to Skills in Automation. My name is Ash and today we're going to look at how to deal with Excel errors that occur within an Excel cell. Let's briefly discuss the common Excel errors in a very generalized way, and we won't go through all of them in detail. Starting with #NA, which I refer to as the lookup error. It mostly occurs when a lookup formula is unable to find a match for the reference value. You would expect a typical corporate Excel reporting file to be littered with these. #value occurs when you're trying to do a mathematical operation on different data types. Example, if you try and add a cell with a number to a cell with a text. #div0 occurs when you try to divide a number with either a 0 or a cell with no value. We'll see examples of these errors in this video. And #name occurs when you have misspelled the name of a function or maybe even a range in your formula. For #ref, suppose you have a VLOOKUP against data in a column and you delete that column, then you'll see this #ref error. #null and #num are less common. #null would be due to an invalid intersection of cells, while #num occurs when a formula contains invalid numeric values. Okay, next, from the perspective of VBA, let's see why these matter. They matter in VBA for the same reason they matter in Excel. We can't read them directly from the cell. Any attempt to do so in Excel will return us the same error value, which is kind of fine, but doing so in VBA will break the macro, as we will get a type mismatch error when we attempt to read the cell value. So let's first look at Excel and then go to VBA, because the solution in VBA is the same as that in Excel. Okay, so here we have some #NA errors in column C because smooth peanut butter does not have a match in our reference table. And you can see two data sets out here. In the top data set, column C has formulas, while in the bottom set, column C has values. Point here is that the behavior of the error will be the same if the cell has a formula or the cell has a value. Let's try to read the values in column C in an if statement. We'll check whether the value in column C is relish. If it is, we'll assign it group A, and if it isn't, we'll assign it group B. So this is our basic if statement. Let's press enter and drag this all the way down. We get the same #NA error as we have in column C. The way around this is to use an is function. And to check specifically for a #NA error, we can use an ISNA function. ISNA will return a true if there is a #NA error and false otherwise. So we'll use this same if statement, but this time we'll wrap this inside another if statement. So if ISNA and the value in C3. If this returns a true, we will return the text value unknown. And if it returns a false, we will just return back the results of this if statement. Okay, so close the bracket here, press enter. So this time our error is gone, and let's drag these down. Great. Another alternative is ISERROR. ISNA only works on #NA errors, whereas ISERROR works on all errors, including #NA, #name, #div, etc. So we'll just take this formula, paste it here, and replace ISNA with ISERROR. Enter. Great. We get the same results. You could almost call ISNA as a subset of ISERROR. I will suggest to use ISERROR unless you're specifically after identifying #NA errors. And just for information, you also have ISERROR, which will return a true for all errors except #NA errors. And there is IFError, which can catch all errors as well. But to keep things simple, we will just stick to ISNA and ISERROR functions in this video. And before we move on to VBA, let's drag these formulas all the way down and delete this off. And we can see that the formulas will give the same results, which means we can apply the same logic to cells with formula errors and cells with just error values. Okay, let's move on to VBA, Alt F11. Our problem statement for this VBA section is that we want to loop through our data columns and check whether there are any Excel errors. If there is an error, we can choose to do one of three things: change the underlying value of the cell with the error in it, or change the background color of that cell, or alert the user that there is an error in the worksheet, which they can then manually fix. Come back to VBA. Let's create a sub. We'll declare and assign a worksheet variable. declare and assign an iteration variable for the loop. And our loop will go from row number 2 to row number 6, which are basically our rows with data in it. First, let's just try to read the cell value in column C and message box something. So if the value in the current cell in column C if it equals to relish, then we'll just give out a message saying found. Okay, let's run this. And we get the type mismatch error. Hit debug, and we can see the error is when it's trying to read the value in column C, which has the error value in it. Now, we will get the same error if we use value 2. However, we can at times use .text. Let's put a breakpoint here and run the macro. So with .text, we would not get an error, but there are a lot of conditions to deal with when it comes to .text. And that's mainly to do with formatting inside the cell. And I would avoid using it. We'll just stick to .value, which will give us the error. So to address this reading of the cell value, we will use the ISNA function. We will first check whether the cell value throws an error, and if it does, we will do something. Now ISNA is a method of the worksheet function object, which allows us to use Excel functions in VBA. So let's delete this off. So we can go application.worksheet.function.isNA. And if this returns a true, that would mean that the cell has a #NA error value inside it. And if there's an error, we can try changing the cell value to a blank or to an unknown, or we could change the background color to yellow or alert the user of the first instance of an error. Okay, we can choose to run any of these. Let's go with changing the background color to yellow. Let's run this. Come back to our sheet, dataset 1, and yes, the cells with #NA have now turned yellow. Great, seems to be working. And we can even use ISERROR. Now ISERROR is a VBA function, which means we can use it directly. So let's copy and comment out this block of code. Delete out this part. And as I mentioned, we can use ISERROR directly. And if there's an error, we'll change the cell background color to yellow as we did in the previous code. Let's run this, come back to dataset 1, and yes, it's all turned yellow. My suggestion would be to keep it simple and just use ISERROR. If you're just interested in addressing all errors in one go, we can use a SpecialCells method of the worksheet cells object. So in this worksheet, we have errors in multiple columns, and there are all different errors. In fact, we have #NA, we have got #value, and even #div0. We can basically identify each cell with an error in it and do something with the cell accordingly. However, this is where we need to consider whether our data set has formulas or just error values, because our approach will be different for both. And before we head back to the VBA code editor, we have 3 worksheets out here. Dataset 1 has formulas, dataset 2 has only values, and dataset 3 is a mix of values and formulas. Let's go to the VBA editor, Alt F11, create a new module, create a new sub, declare and assign a worksheet variable. We'll first just look at dataset 1, which is the worksheet with just formulas. Now we will use a with statement to identify the error values using the SpecialCells method. So with, it is the method of worksheets.cells dot choose SpecialCells brackets, and we get our IntelliSense. This method can take 2 parameters, cell type and value. But let's look at this Microsoft Docs page where it's more clearer. So what type of cells do we want to look in? Let us consider that we want to look in cells with formulas in them. We will choose Excel cell type formulas. So come back, we'll make the bracket reappear, choose formulas, comma, and for value, come back to the Microsoft Doc page. What type of cell value do we want to capture in our results? We want to capture the errors, which is Excel errors. Copy this, come back to our code, paste it here, close the with statement. Once the range is identified, let's turn it yellow. So dot interior dot color, and we'll just change it to yellow. Great. Let's run this. Come back to our worksheet. All the cells with error values have now turned yellow. Awesome. Change this back. But the problem with returning range objects is that if no match is found, VBA will throw an error. Let's try this out. So we have one worksheet here with basically just good data. It's called good data. Copy, come here, change the worksheet name, and let's run this now. And we get an error that no cells were found. To solve this, we need to put in some error handling. We'll put in a resume next statement to move to the next line of code if an error is found out here, and then reset it to 0, or in other words, return VBA to normal error handling protocol after these lines have cleared. Let's run this. It ran, there were no errors. Great. Now let's come to dataset 2, which doesn't have any formulas, but does have error values. How do we address this? Simple. Let's go to our Microsoft Docs page. So last time we chose formulas. This time we'll choose constants. So basically we're looking for cells containing constants. Let's copy this, comment it out, paste it below, and replace formulas with constants. And change our worksheet to dataset 2. Great. Let's run this. Come to our worksheet, and we have our expected results. All the cell values with errors have now turned yellow. And finally, now what if our cells have values and formulas and we want to identify all the errors? So here, column C has values, column G has formulas, and column I has formulas. Well, we can basically use both these statements inside an error handler. Comment this out. So the cells with formulas will get captured with this piece of code, and the cells with constants or just error values will get captured by this piece of code. And change this to dataset 3. Let's run this. Come to dataset 3. Great. All the cells with error values have now turned yellow. Now there are many alternatives that you can do out here. Let's check one example. Suppose you just want to check whether there is at least one error and exit the sub if there is. Let's declare and assign two range variables to hold the results of the two special cells method. So we can delete all this part out. And we'll assign the results of this special cells method to this range. While assigning an object variable, we need to set it. So set the range object variable equals to the special cells method. And we'll do the same for the special cells method with constants. And even if one of these is not empty, or in VBA lingo, if the ranges are not nothing, then we can alert the user and exit the sub. So which basically means that if the special cells method returns any result, the range variables will get populated. And if that happens, we will alert the user and exit the sub. So the right way to write this is if not the first range variable is nothing. So this basically reads if this is not nothing, or the constant variable is not nothing. And in that case, we'll pop up a message and exit the sub. So let's run this on dataset 3, which does have error values. Let's put a breakpoint out here, run the macro. Yes, this condition is met because in our particular case, both the ranges are populated. So here's a message box, F8, we get that, and exit the sub, F8, great. And just to test this, let's run this on our good data worksheet. This time we will not expect any message to pop up. Let's put a breakpoint here, run the sub, it ran, and the message box did not get triggered. So great, everything seems to be working fine. So far, we have seen how to loop through a range of data and identify if there is an error. And we have also seen how to determine whether errors actually exist within an entire data set. Now, we will go through how to determine what type of error actually exists and deal with each error type individually. I will admit, we are entering overkill or TMI, that is too much information zone. What we have done so far is probably good enough for most scenarios, but VBA lets you go even further. So let's push on ahead. We will do two things now. First, we will loop through each cell in our data range, and in the loop, we will use a function to determine what type of error exists in each cell. The function we are going to use is CVErr. This function can take a parameter. The choices are on the screen, which is basically one for each error type. The result of the function with the specific parameter will be a real error value, which will equate to the error value we have seen in our cell. What we will do is use a select case statement to check whether the error value in our cell equals to the output of each parameter. If we find a match, we will know what error type exists in the cell and we can do something accordingly. For our example, we will color code each cell with a different color based on the error value. Let's create a new module, create a new sub, declare the worksheet variables, declare a range variable for each cell that we're going to loop over. Now, we will use a for each loop to loop over the current region of the entire data set. So for each range cell in, now to choose the current region, we need to call it from any cell within that current region. So we'll call it from range A1. And we'll close the for loop. Actually, we should be using dataset 3. So inside this for loop, first we will check if there is an error in the cell. We can use the ISERROR function. So if ISERROR, the value of the current cell, which is range cell dot value. So if this returns a true, then close the if statement. Now we will use a select case statement to check the value in each cell. Select case. What are we checking? Checking the value of the cell. Let's end the select case. And what are we going to check it against? We will check it against each parameter for the CVErr function. Let's do it first for the #div0 error. And a parameter for the div0 error is, and if there is a match, we will change the cell background color. Okay, and we can do this for the rest of the parameters, assigning a unique color index to each of them. But before we do this, we need to correct this statement which is in red. This VBA's way of telling us that there's some error. And the error is that this should not be end case, it should be end select. I'm just going to paste over the rest of the cases. And lastly, if the error is not one of these error types, we will assign it a different color. Okay, let's just come to dataset 3. Our expectation on running the macro is that each error type will be highlighted in its own unique background cell color. Come back to the macro. Let's run this. Run, come back to the worksheet. Great. Each of the error types seem to have a unique color. So great, it works. From our perspective, the value I suppose we can get from this is that we can see multiple colors after running this sub, which means that there are multiple error types. And you don't need to just assign different colors. We can do something else. For example, if the cell has a #NA error, we can just change the cell value to blank. And if it has a div0 error, we could change the cell value to say 0 and so on. Great. And that's our code. Let's go to the wrap up session. And that's it for the video. All the code covered here will be available on my blog site, skillsandautomation.com. Link will be in the description below. Please let me know if you found this video useful or if you have any other feedback in the comments below. And if you did find some value, please do like and subscribe. Thanks and see you in the next one.